So the assumption will take like this. Good conceptual questions will be asked in this section. You be careful. This is the last part of system, no, where some very good conceptual things can be analyzed. So let me take a strip. I'm assuming a strip. So this particular thing is moving with a velocity, no? So and here the charge is present. So let the length of this let it be equal to dx, and the length of this part let it be dl. Since you are familiar with this one, or dr, anything you, if you want to take it here. Now look at this, some sort of how much of charge is present in this dq charge, and what is sigma. So what is the how much of charge is present dq? So dq, what we can write it here. So this can also be dr. This width will be dr, no? So dq, what you can write sigma into dx into dr. So this I'm able to define the charge. Okay, after this, how to get the field? We were asking something field, no? So go back to, shall we take help of Biot-Savart law? So this is equivalent to current carrying sheet. For again, for your understanding purpose, I'm bringing this concept of sheet. So it is as good as for me what happened. There is a sheet now. From where the current is coming now. So this should be the out of plane. Out of the plane, I'm taking this. Rate of flow of charge should be what? Should be the current too. So is it, look at the green color region, the charge is there, the charge is in motion. And what is V? We can write dx by dt from the geometry. So is there, and let me apply Amperes loop. So where is the Amperes loop? I'm going to bring the Amperes loop like this. Only one problem, if you can go back to again the basics yesterday what we have learned, no? So this will be the, and the current let it be like this, and we assumed an ampere path. No, this is what dr, no? It is enclosing some current. So how to take help of all this data, and this is like a sheet. So how the B bar, this particular, the charge flowing what pen, as good as like a current di is flowing in this region, di is flowing. So di is what you can write dq by dt. So how much of current here is di. So di is what we can write dq by dt. Due to this di, how the field will be here in this direction, and the field here will be in this direction. So or here if you showing the field, so I'll and what about here? This will be zero, no? Here dl, if you take it, this will be zero. So applying the this one, so 2b or say bdr. There's a basic problem. Everywhere the application will come. Ampere's circuit law. So what about the value of b bar dot dl? Value of b bar dot dl for 1, 2, for 1, 2, for 2, 3, and 1, 4. It should be zero, no? It will be like this: b dr cos 90. it will be 0. Similarly for 1 BDR cos 90 0. So I'll add up only due to 1, 2 and 3, 4 or finding difficult. So you break up everything 1, 2 BDR cos 0 degree 2, 3 cos 90 3, 4 BDR cos 0 4, 1 BDR cos 0 is equal to net current enclosed. So mu naught into di, I'll write it. So these two shaded quantities, these two will be 0 cos 90, no, it is. These two will be tending to 0. Simplification of this, it will be 2 BDR is equal to mu naught. What to write di? Di is what? dq by dt. Further, dq by dt, what you can write it as? What is dq? Sigma dx dr by dt. Sigma, okay, dx by dt, what we can write as v. So this is dr. So finally, what is b equal to mu naught sigma v by 2. So this is a magnetic field produced by the large non-conducting charge sheet. That's strict condition, it should be large. If the finite, I think the field will, will not be uniform and we can't write directly b dr cos 0. I'm making things clear. Large non-conducting sheet. Yeah, better, I think in exam, you can't determine so much, no? Better to remember this, like a Biot-Savart law. Like that also due to non-conducting charge sheet, due to disk, different systems. And where that field will be below the plate, above the plate, and will be uniform. Is it okay? So I think three-dimensional diagram, little bit very difficult. I'm just showing few arrows above the plate, below the plate. Directed, tangential to the plate, and will be below and above. I'm showing that arrows here. Okay, this is about the B bar due to large non-conducting sheet here. Okay, just one small application. Okay, somebody is asking, see once. Okay, this that dx by dt is what we have replaced with v.